Okay, let's dive right into this explainer, because today we're looking at a paradigm shift in tech that is honestly both fascinating and absolutely necessary. I want to start off with a number that completely changed how I view my own daily AI usage. Because, we all love the magic of typing a quick prompt and getting an instant essay, a hyper-realistic image, or a flawless block of code. But we really need to ask, what is the hidden cost of all that convenience?
2 to 4.5 grams. That right there is the estimated amount of carbon dioxide produced by just a single generative AI query. Now, I know that might not sound like a huge deal at first glance, but when you compare it to a standard web search, which is just a tiny, tiny fraction of a gram, it is drastically higher. AI is incredibly powerful, no doubt about it, but it's definitely not weightless.
Let's put that into a physical perspective we can all actually relate to. Typing just 15 to 20 prompts into an AI assistant consumes the exact same amount of energy as boiling a kettle of water. So, every single time you're iterating on an email draft or asking an AI to brainstorm some quick ideas for you, you are essentially firing up that kettle.
And man, it scales up incredibly fast. If you and your team hit 100,000 queries, and let's be real, that is way easier to hit than you'd think for a business integrating AI into its daily workflow, you've essentially just booked a round-trip flight from San Francisco to London in terms of your carbon footprint. A full ton of CO2 just from software queries.
When we zoom out, these little micro-habits compound massively at the global level. The estimated electricity consumption for data centers worldwide reveals an energy appetite that literally rivals entire countries. The sheer scale of the infrastructure required to sustain our current AI trajectory is just staggering. Because behind the seamless magic of your favorite AI tools are these massive, centralized facilities. We're talking about data centers running tens of thousands of GPUs continuously. They require immense amounts of electricity and, frankly, staggering amounts of water just for cooling, which contributes significantly to a massive global emission spike. This is the traditional, resource-heavy paradigm of modern AI.
Which brings us to Section 1, the AAA challenge.
This escalating resource dependency means we're essentially hitting a brick wall, characterized by three main factors. First, you have unsustainable economic costs. Believe it or not, fewer than 1 in 5 companies actually achieve a sustainable ROI from AI, simply because the compute costs are just way too high. Second, there's that severe environmental toll from the massive energy drain we just talked about. And third, limited reach. Because these models require such massive, expensive infrastructure, small to medium enterprises and emerging markets are basically locked out of the AI revolution entirely.
So, how do we actually fix this? Next time you casually ask an AI to write a grocery list or summarize an article, we really need to ask ourselves, is there a better way to build intelligence without, burning the planet and bankrupting the users? Well, enter Frugal AI. This is a much-needed paradigm shift. It's an intentional approach to designing AI systems that are resource-efficient, affordable, accessible, and above all, sustainable. I found this concept so fascinating. It's actually inspired by the Hindi concept of jugaad, which roughly translates to resourceful improvisation. Frugal AI proves that in the world of machine learning, bigger isn't always better. It's all about doing more with less for more people. What's really interesting here is how Frugal AI completely flips the traditional mindset on its head. Traditional AI takes a scale-first, brute force approach. Massive data sets, massive compute, astronomical costs. Frugal AI, on the other hand, uses a constraint-driven, problem-first strategy. It relies on something called data parsimony, basically using only the small amount of high-quality data you actually need. And this allows surprisingly powerful models to be accessible directly on tiny edge devices, rather than relying on giant server farms halfway across the world.
To pull this off, developers don't just throw more servers at a problem. They use a highly specialized Frugal toolkit. They use clever techniques like model pruning, which smartly trims away unnecessary connections in neural networks, or quantization, which compresses the model so it requires far less memory to run. By running these highly compressed models directly on low-power hardware, a concept known as edge AI, they drastically reduce latency, energy use, and those crazy cloud computing costs.
Moving right along to Section 2, sensing with open hardware.
Let's move out of the cloud and into the physical world. When you combine the software efficiency of Frugal AI with open-source hardware, you get incredible initiatives like the Frugal AI Hub at Cambridge. You've got these interdisciplinary teams finally stepping away from closed, expensive systems. They're bringing together researchers, everyday citizens, and developers to embrace citizen science and open hardware. They're creating lean technologies meant to solve highly localized problems, totally skipping the multi-million-dollar price tags.
A perfect example of this is the development of ultra-low-cost environmental sensor networks. Researchers at the University of Toronto designed this self-organizing mesh network using something they call the cotton candy node. Get this. This little device costs less than $15. It runs on a long-range, low-power LoRa network, and here is the absolute best part. It can transmit crucial environmental data for over a year running on just 2 standard AA batteries. Pretty wild, right?
Section 3. Frugal Innovation in Action.
Let's apply this MacGyver-like ingenuity to a massive, real-world sustainability challenge: utility-scale solar farms. Currently, finding broken panels requires expensive drones or massive centralized weather stations. But with frugal innovation, operators can print incredibly cheap laser-induced graphene, or LIG sensors, and just attach them directly to the solar panels. These sensors hook up to those $15 LoRa nodes we just talked about, forming a massive wireless mesh network to monitor localized overheating or wind damage across thousands and thousands of acres.
Now, the crucial point here is how the AI actually plays into this. If these sensors streamed raw temperature data every single second, the network would crash, and those AA batteries would die instantly. Instead, a lightweight Frugal AI model runs locally, right on the sensor's microchip. The node only spends battery power to transmit a tiny alert when it detects a real anomaly, like if a panel is actually breaking. It's smart, it's lean, and it's incredibly efficient.
And finally, Section 4, a sustainable, inclusive future.
You see, this whole approach isn't just some clever cost-cutting measure, it's a fundamental reimagining of technology. By embracing open hardware and frugal machine learning, ecosystems like Cambridge are actively democratizing innovation. They're ensuring that cutting-edge AI technology serves a small-scale farmer monitoring soil conditions in a remote village just as well and just as affordably as it serves a massive multinational enterprise.
I want to leave you with this provocative thought directly from the white paper. True innovation isn't measured just by compute power, but by human impact. As we shape the next decade of technology, we are facing a really critical choice. Are we going to build intelligence that merely consumes energy and resources, or will we champion a frugal AI that is efficient enough to scale, inclusive enough to serve, and ethical enough to endure? Thank you so much for exploring this explainer with me today, and hey, keep asking those big questions.